Uh, Very good. I'm going to share my screen with all of you. This is a PowerPoint program, and it is about astronomy and space science from the time when this country got started 250 years ago. And hope that all of you have an interest in it. And afterwards, if you have a question or questions, I'll try my best to answer them. You can either post it on the chat board or you can unmute yourself and ask me directly. Anyway, I want to thank the Richard Salter Storrs Library for hosting me again here. I've done several different virtual lectures for this library, and it's been a privilege to speak for them on other occasions, and so is the case again for tonight. So let's talk about Yankee Stargazing. And as you are well aware, this is the 250th anniversary of our country marking its independence. And the very special word for that is semi-quincentennial. Some of you of a certain age may remember 50 years ago when we had the bicentennial. Well, this is the semi-quincentennial. And again, we'll be talking now about astronomy and space, going back all the way to the beginnings of this country, even before the beginnings of this country. Now, from the very beginning, science in general enjoyed a prominent place in colonial America. Harvard College was founded way back in 1636, just 16 years after the first settlement in Massachusetts. Now, from the start, natural philosophy, that's a fancy way of saying science. Science or natural philosophy had its niche in the curriculum next to moral philosophy, metaphysics, languages, and rhetoric. However, it is an interesting point to, and rarely mentioned, that at the time of the signing of the Declaration of Independence in 1776, astronomy was probably the most highly developed of all the natural sciences. Now, physics was considerably less developed than astronomy, but still ahead of the other natural sciences. Chemistry, in the modern sense, did not yet exist. Now, chemists did know how to make certain substances, mostly of a pharmacological value, but that was about the sum total of their knowledge. Electricity still had yet to be discovered, although a few electrical phenomena were known, such as lightning. Zoology and botany were still in the state of collecting specimens and information without much understanding of either natural relationships or biological functions. Meteorology, and that's my advocation, meteorology was a thing of the future, and geology was likewise. So was metallurgy. And medicine, well, medicine kind of fumbled, if you will, and surgery, Lord help you if you had to have surgery 250 years ago. That was kind of like, I guess you could say, in the stage of benevolent torture, with only occasional successes. Geography was doing relatively well, but still had enormous gaps to fill, especially so comprising most of the interior of Africa and virtually much of the area below the equator, the southern hemisphere. But astronomy in particular, was cultivated both in and out of the classrooms. And the reason was many and complex. For one thing, astronomical knowledge was needed in everyday life in order to navigate the oceans, for example, survey boundaries, chart the wildernesses, and also to tell time. The ordinary person, in fact, was probably much more familiar with the sky and the heavens in the year 1700 or 1750 or anytime during the 18th century, far more familiar with the sky than the average person is today. Now, this gentleman that you see on the screen was an interesting person. He was the governor of Connecticut, John Winthrop Jr., and he brought to America the first notable telescope to the New World in the year 1663. It was 3.5 feet in length. You can see it behind him. And as often is the case today, politics and administration leave little time for the practice of astronomy. So in the year 1672, Governor Winthrop presented this telescope to Harvard, where it might be put to more use. And during its 92-year history, the Winthrop telescope had many distinguished guest observers, including the remarkable Increase Mather and his precocious son Cotton Mather, both Puritan clergymen and authors in colonial New England who wrote extensively on the theological, historical, and scientific subjects. The Winthrop telescope, I'm sorry to say, came to an abrupt end on the night of January 24th, 1764, when a catastrophic fire ravaged Harvard Hall and destroyed nearly all the scientific books and apparatus that it contained. This telescope that you see here on your screen is a 15-inch telescope, and that became known as the Great Refractor and was installed in Cambridge in the year 1847. For 20 years, this telescope was the largest telescope in the United States, the most significant American astronomical instrument and equal to the finest in the world, and it formed the nucleus for the development of the Harvard College Observatory. Now, we all know that February sometimes contains a leap year, but a little quirk in history, American colonists once had to leap weeks into the future. The British, and by extension the colonists, waited until 1752 to make the jump from the calendar created by Julius Caesar in 45 BC to the one commissioned by Pope Gregory XII in 1582. That's our current standard. So if you were in Europe in 1582, October of 1582, note that Thursday, October 4th was followed by Friday, October 15th, because there was at least a 10-day error, if you will, in the Julian calendar, the calendar that was first put into place by Julius Caesar in 45 BC. By the time Pope Gregory came around in 1582, he ordered his astronomer, who was named Clavius, to come up with a new solution to this. And Clavius said, well, the thing is that we're 10 days off, so we're going to have to make up those 10 days somehow. And so they did. So October 4th, 1582 was followed by October 15th, 1582. They landed about 10 days off the mark. Now, as I said, the colonists did not shift from the Julian calendar to the Gregorian calendar in 1582. They continued with the Julian calendar until 1752, and by that time, the calendar was off by 11 days. So here was the solution. 1 second after midnight on September 2nd, 1752, it became September 14th. Of course, all birthdays followed suit, including George Washington's. Now we know today that Washington's birthday is celebrated on February the 22nd. Washington supposedly was born February 22nd, 1732, but I say supposedly because if there was a calendar hanging on the wall when George was born, or where George was born, it would have read February 11th, 1731. That's according again to the Julian calendar. And you may say to yourself, well, why the difference in years, 1731 to 1732? Interestingly enough, in the Julian or the Roman calendar, February was the final month of the year. That's why back in 45 BC, Sisigines, the astronomer who worked for Julius Caesar, said we ought to fix this by adding an extra day every 4 years. They had determined way back then that the tropical year was 365 and a quarter days long. So they said, okay, well, we'll simply, every 4 years, we'll simply add an extra day. But it wasn't exactly a quarter of a day. It was slightly less than a quarter. That's why things got thrown off and got out of kilter by the time we got to the 16th century, and that's why we went with the Gregorian calendar. But again, if there was a calendar hanging on the wall when George Washington was born or where he was born, it would have read February 11th, 1731. George celebrated his 20th birthday on February 22nd, which is the date that we now use today. Now, in the American colonies, during the 17th and 18th centuries, the almanac stood next to the Bible in importance in daily life. It gave the times of when the sun and moon set, the times at which certain stars would reach their highest points in the sky on different days of the year, lunar phases, the aspects of the planets, some astrological lore, some Earth-based information of the condition of principal road conditions between cities, tips on husbandry, and of course, weather predictions, which I guess continues to this very day with the Farmer's Almanac. After 1700, there was cutthroat competition. A best-selling almanac could support its printer well into the year ahead, but it had continuously had to fight off counterfeit publications bearing the same name. One of the hottest selling ones of the 18th century was Benjamin Franklin's Poor Richard's Almanac from Philadelphia. In mid-century, it sold between 50,000 and 100,000 copies annually, and that was in a country with a population of about 2.5 million people. Now, back in the day of the 1700s, observations were made with telescopes of the sky and of various celestial objects. And there was of course, no photography back in the 1700s. So we have to rely on these images that were rendered by artists at the time looking through their telescopes. For example, what you see here is a sunspot. And I thought back in the day that sunspots might have been holes in the sun, but really sunspots look dark because they are magnetic storms, cooler, much cooler than the surrounding areas on the sun. The surface of the sun, the photosphere, is 11,000 degrees Fahrenheit. Well, sunspots are on the average of 7,000 or 8,000 degrees Fahrenheit, and so being cooler by 3,000 or 4,000 degrees, they look dark against the bright sun's surface. So that's why they look like spots. And this particular view here was of an astronomer rendering a view of a sunspot, and you can almost see the magnetic lines between these two spots that are on your screen right now. But there are other objects too. There was the moon. Oh, the moon. Probably the number one object that most people looked at through their telescopes. The moon, with its craters and mountains and valleys. The moon, which caused people, when they looked up at it, either with the naked eye or especially with telescopes, to wonder, would we ever be able to get a chance to get actually up into space and perhaps even explore the lunar surface? Well, of course, as you know, we did, but it would be a couple of hundred years before that finally would take place. Other objects, too, like the planets. Mars. Oh, Mars. Right down through the ages. Mars is an exciting object because of its ruddy color. Mars, seen through the telescopes of the Italian astronomer Schiaparelli in 1877. Mars with those strange lineations called canale, translated canals, exciting the spirit of man because canals are, well, something got lost in the translation. When Schiaparelli, an Italian, said canale, he meant channels. Channels are a natural phenomenon, but when they were translated, the word canale was translated into English on this side of the Atlantic, it came out canals, and canals are different. Canals have to be made by someone. Are there Martians? Were there intelligent beings roaming around on the surface of Mars? We've got to go there, said man. We've got to go there and find out what Mars is like. We did, but again, it would be centuries in the future. Other planets, like Jupiter. Jupiter with its great red spot, and Jupiter with its retinue of moons. You see two of them here, the famous Galilean satellites, casting dark circular shadows onto the cloud tops of Jupiter. Jupiter, the largest planet in the solar system. And another wonder of the solar system, Saturn. Saturn with its glorious rings. I don't know how many of you have had the opportunity to look at Saturn's rings through a small telescope, but I tell you, if you have not had that pleasure, the next time you get a chance, please do yourself a favor and look. They seem to glow with an inner light. Oh, of course, the rings are illuminated by the sun, and they're not solid disks the way they appear, but rather particles of matter about 10 miles thick, and the particles from within reflecting sunlight, even as the particles near the surface do, giving this illusion of an inner glow as we look at the rings of Saturn through a telescope. Other objects beyond our solar system, like the Great Nebula in Orion, a tremendous cloud of gas. This is an incubator, actually, of stars. Stars we have seen that have actually been born out of the gaseous stuff that makes up this cloud. So very large is the Great Orion Nebula that it would take a beam of light 26 years to go from one side of it to the other, traveling 11 million miles every minute of those 26 years. Other strange objects like comets. Comets which appeared like stars, except they had an appendage that trailed behind the head. Astronomers, well, not astronomers, but people who looked into the sky way back then thought of them as a head of hair. Comets were known as hairy stars. And because they were so different than anything else that appeared in the sky, people thought that they might be omens, evil omens. There was an ancient jingle, 8 things there be a comet brings, when on high at the horrid range, war, famine, plague, and death to kings, wind, earthquakes, floods, and dire change. Today, when a comet appears, we can enjoy it. It's a beautiful sight in the sky. They're few or far between in terms of the comets that are large enough and bright enough to be easily seen with the unaided eye, maybe 1 or 2 every 15 to 20 years. But if a comet were to appear a couple of hundred years ago, they were something to be feared because they were thought to be a sign, a signal that something bad was soon to happen. And other mystifying sights in the sky. Sometimes they'd look up and they'd see what appeared to be a star falling from its fixed position in the sky. We call them meteors today, although we know now that they are not really stars. They're really tiny particles crashing into our atmosphere at high speeds, 30, 40 miles per second, and friction with the atmosphere raises them to white heat and causes them to trail behind for a few seconds an incandescent trail of light, which gives the appearance of a star falling out of its fixed position in the sky. And other celestial wonders which appeared every now and then, the northern lights, usually confined to the polar regions, northern Canada and Alaska. But when we get hold of a major solar eruption, a major flare or outburst on the sun, that flare will send toward the Earth a stream of invisible electrified subatomic particles, which crash into our atmosphere hundreds of miles above the surface of the Earth, and upon collision with other molecules, oxygen molecules, create light, and these lights spread across the northern sky. If the disturbance, the solar disturbance, is large enough, it will push the visibility zone much further to the south and allow us in our latitudes to see it. I don't know how many of you remember back in 2024, we had 2 displays of the northern lights that were visible, one in May and one in October, plainly visible to anyone who had a dark sky, lighting up our skies with different colors, different variations of shapes. You see here a fan-shaped aurora, but there are auroras that look like curtains that flow in the nighttime breeze. Patches of light here and there, an amazing sight to see. I'm just taking a little brief break here and taking a little sip of water to lubricate my throat. Now, by the early 18th century, again, colonial Americans were beginning to contribute significantly to European science. In astronomy, as we just noted, observational contributions were accounts of a variety of astronomical phenomena. Benjamin Franklin, who we mentioned with the Association of Poor Richard's Almanac, Ben Franklin was an author, a printer, a politician, diplomat, inventor, and scientist. He represented the unschooled original thinker, an inventive genius so characteristic of many early Americans. Among his scientific interest was astronomy, and he no doubt was eagerly looking forward to the night of November 1st, 1743, when a total eclipse of the moon would be visible from his home city of Philadelphia. Totality would occur at a convenient time, just after 9 o'clock in the evening, and the total phase would last an unusually long 100 minutes. Unfortunately, a spell of unsettled weather dashed his hopes and all the other people in Philadelphia who wanted to see this eclipse. It prevented everybody from observing it. From what we can gather, a full-fledged nor'easter, or possibly the remnants of a of a hurricane blew in just before the eclipse was just to get underway, complete with clouds and heavy windswept rain. Now, sometime later, long after the eclipse was over, Franklin received a letter from Boston from one of his brothers, and the letter contained rather surprising news. The lunar eclipse that was clouded over in Philadelphia, the lunar eclipse was seen in Boston in perfectly clear skies, and the stormy weather that blocked Franklin's view didn't arrive until after the storm had finished. Now, Franklin was perplexed. He felt that, and remember I said at the very beginning, meteorology was a science that was far in the future in terms of forecasting. And this was one of the things that was a problem, trying to forecast the weather back in the 1700s. Franklin felt that because the winds in Philadelphia were blowing strongly out of the northeast, hence the reason why we believe there might have been a nor'easter occurring at that time, it was blowing strongly from the northeast, from the direction of Boston, that this was where the storm originated. This puzzled me, he wrote, because the storm began with us so soon to prevent an observation of the eclipse. And being a northeast storm, I imagined it must have begun rather sooner in places farther to the northeastward than it did in Philadelphia. Now here we have a map, what purportedly or supposedly the weather map looked like on the day when the eclipse was to be visible in Philadelphia, but was clouded over and rained out in Philadelphia. Apparently there was a storm off the mid-Atlantic coastline. And in this zone that you see here, where my cursor is pointing to, this was the zone of clouds, wind, and rain, which encompassed not only Philadelphia, but down toward Baltimore and further north and east up toward New York City. So if we were in New York, if you were living in New York at the time, you would have missed out on the eclipse. But here's Boston, and look at that. Boston was far to the north and east, and also out of the zone of the unsettled weather. So they indeed did get a clear view of the eclipse. They had to wait until the storm continued to move up the eastern seaboard and push this rain and wind system into New England. But at the time when the eclipse was occurring, they had a clear view, as Franklin's brother had mentioned. So Franklin began to gather weather observations. I guess you could say he was also the very first weatherman, or the very first meteorologist. He began gathering weather observations from around Philadelphia and other locations, and eventually determined the proper direction of movement for storm systems. In a letter in 1749 to clergyman Jared Elliott, Franklin pointed out that the storms apparently occurred earlier in the region toward which the wind is blowing. So if a wind is blowing out of the northeast, it's blowing toward the southwest, and began later for places in the direction from where the wind was emanating from. He would later write a treatise on the behavior of coastal storms along the Atlantic seaboard. And to think, it all began because he was deprived of the view of the lunar eclipse of 1743. The beginnings of meteorology may have begun with old Ben Franklin. Another person who had an eclipse in mind was Samuel Williams. He was a professor at Harvard and led an expedition to Penobscot Bay, Maine, to observe a total solar eclipse on October 27, 1780. Now, here's an interesting point. As it turned out, this eclipse took place during the Revolutionary War, and Penobscot Bay lay behind enemy lines. But fortunately, the British granted the expedition safe passage, citing the interest in science above political differences. Can you imagine if anything like that were to happen today? I doubt very much if that were to happen in our modern era, but back in 1780, the British said, okay, we're not going to interfere. You folks want to observe this celestial phenomenon of an eclipse? Go ahead. We will not bother you. We will not take you prisoner. Because again, as I just mentioned a few moments ago, science above political differences was far more important. And yet, in the end, this whole procedure was all for naught. Williams apparently made a fatal error in his computations and inadvertently, get this, positioned his men at Islesboro in Maine, outside the path of totality, likely finding this out with a very heavy heart when the waning crescent of sunlight thinned, got very, very, like almost like a sliver, a hairline sliver, and then before totality came, completely slid around the dark edge of the moon and started thickening. But Williams did observe one event which we now know today as Baily's beads. Here's a diagram that he made of the maximum of that eclipse. And again, he saw beads of sunlight shining apparently through mountains and valleys on the edge of the moon. The lunar edge of the disk of the moon is somewhat like a serrated saw. And so the sunlight shining through the mountains and valleys, appearing as beads. There was a person several years later by the name of Francis Baily who did a complete paper on this phenomenon, and for that he had the beads named for him, Baily's beads. But the first person to see Baily's beads apparently was, because of an unfortunate error, Samuel Williams in 1780 at the total eclipse of the sun over New England, over Maine, in October 27th of that year. Now, in applying astronomical knowledge to useful causes, no Americans succeeded more than Benjamin Banneker and Nathaniel Bowditch. Now on your screen is a view of Benjamin Banneker. He became a celebrity in Tidewater, Maryland at the young age of only 22 when he constructed a striking clock. You see the clock here on the left, a striking clock made entirely of wood. That the clock could be built and indeed worked was considered quite remarkable by his neighbors, not only because he was an impoverished farmer, but also because he had modeled his clock after a watch which he had borrowed only once and whose workings he had to memorize. And from that, he was able to build a working wooden clock. Amazing! At the ripe old age of 58, and I say that because back in the 1700s, to live to the age of 58, you were considered a fairly elderly person. But Banneker did indeed make it to the age of 58, and he was introduced then, at that age, to the discipline of astronomy by some books and instruments led to him by his prestigious neighbor and benefactor, George Ellicott. So thanks to George Ellicott getting Banneker hooked on astronomy, we had this. The mathematical and astronomical abilities that Banneker had developed at an extraordinary rate for a man of his years and position. Banneker's mastery of difficult astronomical techniques catapulted astronomy into the public and political domain. His first astronomical work, as you see on the screen here, an unpublished almanac for 1795, circulated by the Maryland abolitionist movement, which led to the 60-year-old African-American being named to the surveying team assigned to the task of determining the borders of the nation's new capital on the Potomac. In other words, the first capital was Philadelphia, but now we have a brand new capital that was being designed, and it was Banneker who was on the surveying team and led the surveying team to the task of determining the borders of what we now know as Washington, D.C. That survey and the 7 almanacs that he later published demonstrated his proficiency in 2 of the areas where astronomy was considered adaptable to the nation's goals. That the thirst for knowledge is not limited to just the youth, and that the process of learning recognizes no barriers of race or creed. Here you see a statue at the Smithsonian Institution of Benjamin Banneker, a highly and well-deserved statue. And I would tell all of you that next time you're in Washington, D.C., I would urge you to go to the Smithsonian and to see this particular statue of this great man. But I can't, because unfortunately, the current administration has deemed that the statue falls under the category of woke, and the statue is no longer on display. It was at the Smithsonian National Museum of African American History and Culture in Washington, D.C., and hopefully someday the statue will be returned to its rightful place. But unfortunately today, this man who helped to design the boundaries of our nation's capital is no longer available to be viewed. Too bad. The next person on our list is Nathaniel Bowditch. He was born in Salem, Massachusetts in 1773, the year of the Boston Tea Party. In 1806, he witnessed the great eclipse of the sun over New England, which lasted almost 5 minutes. And a year later, he collected reports of a spectacular meteor that exploded over Western Connecticut. He was offered the position of professorship of mathematics and natural philosophy at Harvard. In 1818, no more than a person than Thomas Jefferson offered Bowditch a post at the University of Virginia. In 1820, the Secretary of War, John C. Calhoun, offered Bowditch the position at West Point. But Bowditch declined all of these offers on the grounds that, and this is a quote now, he said, quote, "I don't think I'd fit in with those academic types." And he was probably one of the most brilliant people around at that particular time. Well, anyway, Bowditch's family had been shipmasters for over 100 years. So in 1795, he went to sea to merge celestial navigation principles with practical experience. Now, at that time, the book that was most relied upon by navigators of that era was Moore's Practical Navigator, published back in England. Bowditch meticulously pored through this book, found numerous discrepancies, wrote and told Moore about it. They came out with a revised edition, the publication of this revised edition, but that revised edition contained literally thousands of errors. So, in 1802, Bowditch decided to take the bull by the horns, so to speak, and published a new book, patriotically entitled The New American Practical Navigator. And that exceeded 600 pages in length. It was filled with detailed explanations, tables, maps, magnificent illustrations produced from copper plates. It became the Western Hemisphere's shipping industry's standard for the next century and a half. In 1866, the U.S. Hydrographic Office purchased the copyright, and ever since that time, the book has been in continuous publications with regular revisions to keep it current. Bowditch's influences on the American Practical Navigator was so profound that even to this very day, if you were to ask a mariner about a navigation book that they would use for navigation purposes, they would simply say, "I have a copy of Bowditch." And there you see the 2024 edition. It's amazing, but Bowditch changed really the methodology of navigation out on the high seas with his revised book, The New American Practical Navigator, in 1802. And here you see a statue of Bowditch. If you want to see it, it is available to you today. It is a bronze statue and is located in Mount Auburn Cemetery, Cambridge, Massachusetts. It is the first life-sized bronze statue cast in the United States. Another highly regarded gentleman is David Rittenhouse, an American astronomer, inventor, clockmaker, mathematician, surveyor, scientific instrument craftsman, and public official. Rittenhouse was a member of the American Philosophical Society. He was the director of the United States Mint. And David Rittenhouse also made a number of breakthroughs of importance to the United States. He helped, for example, to establish the boundaries of several other states and commonwealths, both before and after the independence, including the boundaries between New Jersey, New York, and Pennsylvania. On the screen here you see Mason and Dixon, and in 1763 they began a survey of the Pennsylvania-Maryland border with the help of David Rittenhouse. But this work was interrupted in 1767. In 1784, Rittenhouse and Andrew Ellicott completed the survey of the Mason-Dixon line, going all the way to the southwest corner of Pennsylvania. And here you see a plaque indicating where the position of the Mason-Dixon line was, again establishing Maryland and Pennsylvania boundary, which began in 1763, halted by Indian Wars in 1767, and continued to mark the southwest corner of Pennsylvania in 1782. And this plaque apparently went up in 1784. Well, besides being able to helped Mason and Dixon with the survey of Pennsylvania and Maryland. He was also an astronomer, and when Rittenhouse's work as a surveyor ended, he resumed his scientific interests. On June 3rd, 1769, he observed a very rare transit of Venus across the face of the sun. How rare? The next transit after the one he saw in 1769, the next one wouldn't be coming our way until 1874, over 100 years later. Rittenhouse used this transit of Venus, and you see here Venus appearing as a dark, small disk against the much larger disk of the sun, Venus appearing in silhouette. And Rittenhouse was able to use the transit of Venus to determine the distance of the Earth to the sun. 93 million miles, what we call today an astronomical unit. This is the approximate distance between the Earth and the sun. The published report of the transit was hailed not only here in this part of the world, the American colonies, but also by European scientists as well. Now, you've heard about breaking the glass ceiling, and here's a young lady who was, I guess, the very first to break that ceiling. Let me take a sip of water here for a moment. This young lady's name was Maria Mitchell. She was an American astronomer, librarian, naturalist, and educator. In 1847, she discovered a comet. Now, if I were to discover a comet, or if you, or maybe two other individuals along with you, discovered it, it would be named after you. The comet would have the surnames of the persons who discovered it. And back in those days, back in the 19th century, early 19th century, people who discovered comets were usually, always, men, male. And so, for example, if I discovered a comet, it'd be known as Comet RAO, Comet Jones, Comet Whipple, Comet Encke, Halley's Comet. But this was a woman who had just discovered a comet. A woman, of all things. And so, in 1847, this new comet became known as Miss Mitchell's Comet. Miss Mitchell discovering the comet in her honor. And she won a gold medal prize for her discovery, which was presented to her by King Christian VIII of Denmark in 1848. Mitchell was the first internationally known woman to work as both a professional astronomer and a professor of astronomy after accepting a position at Vassar College in 1865. She was also the first woman elected fellow of the American Academy of Arts and Sciences and the American Association for the Advancement of Science. Now here's a gentleman who probably would be much, much, much better well known if it weren't for a series of unfortunate, well, what can I say? This gentleman's name is Samuel Pierpont Langley, and he was an American aviator, an American aviation pioneer, astronomy and physicist who invented the bolometer, and he was also the third secretary of the Smithsonian Institution. He was a professor of astronomy at the University of Pittsburgh, where he was also the director of Allegheny Observatory. Now, here's the thing. Toward the end of his life, Langley concentrated his efforts on building a flying machine. He was, in fact, the very first person to develop and fly a heavier-than-air, unmanned flyer propelled by steam power. But here's the thing. When he built flying machines that were manned, all of his manned machines, they suffered mechanical failures. The very last of them was in 1903, and that machine crashed into the Potomac River just 9 days before the famous flight at Kitty Hawk. Had he been able to prevent the snagging of the launch catapult, Langley might have beaten the Wright brothers to aeronautic immortality. Oh well, there you see one of Langley's flying machines. And again, The unmanned versions were great. They worked perfectly, but when he tried flying a manned machine, well, major malfunctions took place. And it was left to the Wright brothers to go into the history books with the first manned heavier than air flight in December of 1903. Now, you remember that 15-inch telescope that I mentioned earlier over at Harvard College? That was the biggest in America. Then construction began of the Yerkes Observatory in Williams Bay, Wisconsin in 1895. While the project was initiated in 1892 by George Ellery Hale and financed by George Tyson Yerkes, the actual construction of the building and installation of the 40-inch telescope occurred between 1895 and its ultimate completion in 1897. The Yerkes Observatory in Williams Bay, Wisconsin was officially dedicated and opened on October 21st, 1897. And here on your screen is how the Yerkes Observatory looks to this day. It is still the largest refracting telescope. That's a telescope that has the lens, the big lens at one end and the eyepiece at the other end. 40 inches across is the Yerkes Observatory scope. And again, it opened officially in October of 1897. The ceremony included University of Chicago President William Rainey Harper and the observatory's benefactor, Charles Yerkes. 25 years later, at the silver anniversary of Yerkes Observatory, a number of scientists and famous astronomers were invited to that commemoration of the 25th anniversary event. And if you take a good look at the number of people or the people who were at that particular ceremony, you may notice one person in particular who stands out. Yes, him, Albert Einstein. Albert Einstein came to this country in 1920. And again, the Yerkes Observatory was celebrating its 25th anniversary in 1922. And Einstein was a celebrity by then and was invited to attend. Einstein used an eclipse of the sun in May of 1919 to prove his general theory of relativity. He did it by demonstrating that the sun's gravity bends starlight precisely as he predicted. During the eclipse, astronomers photographed stars near the edge of the darkened sun and found that their position shifted ever so slightly, confirming the warping of space-time. Einstein's theory of general relativity suggested that gravity is not a force, but a curvature of space-time caused by mass. Therefore, light from distant stars passing near the sun should follow this curve, making the stars appear slightly out of place. This groundbreaking observation confirmed that space is not a static, flat background, but a flexible fabric. The verification brought international fame to Einstein and made him our first celebrity scientist. I guess you could say the gentleman who runs the Hayden Planetarium today, Dr. Neil deGrasse Tyson, is another example of a celebrity scientist. Very, very popular. He's an astrophysicist, but is often asked to appear on talk shows and news reports, and he gives lots of lectures. He's a very popular and very well-known speaker. So I guess it started with Einstein and continues all the way up to this day with Neil deGrasse Tyson. Another person who was very famous back in the early 20th century, another astronomer who was famous, was none other than Harlow Shapley. Pioneering American astronomer, famous for his determining that the sun was not at the center of the Milky Way galaxy, as we thought back then, but he also revolutionized the understanding of our galaxy's size and structure by studying globular star clusters and a special type of variable star known as a Cepheid variable. He was able to place the sun 50,000 light years from the galactic center and vastly expanding the known scale of our Milky Way. That galaxy you see in the lower right, that's the Andromeda Galaxy. We thought it was just a nebula back in the early part of the 20th century until another famous scientist, one who has a spacecraft or a space telescope named after him, Edwin Hubble, was able to resolve the fuzzy patch into stars back in 1923 with the great 100-inch Hooker telescope. At the time, we thought that the Andromeda Galaxy was about 750,000 light years away, but thanks to the studies of Harlow Shapley, we know now that that distance is more than doubled. And now the galaxy, the Andromeda Galaxy, is known to be 2.5 million light years away from the Earth. And we can all thank Harlow Shapley again for, opening up our minds to vastly expanding the known area of the Milky Way. We saw the Yerkes telescope in Wisconsin. Now let me show you the construction of the Palomar Observatory and its 200-inch Hale telescope, which was begun in 1936 following funding secured by George Ellery Hale in 1928 and several years of design and mirror casting. The massive dome was constructed between 1936 and 1939, with the telescope parts arriving on site in 1938 and final assembly unfortunately delayed by World War II until 1948. The 200-inch mirror for the Hale telescope was cast right here in New York State by Corning Glass Works in New York on December 2nd, 1934, and arrived at Caltech in Pasadena, California on April the 10th, 1936. After a failed first attempt, the successful Pyrex blank was shipped by rail across the U.S. in 1936, where it was polished for over 11 years before moving to Palomar Observatory in 1947. The 200-inch Hale telescope at Palomar Observatory was the world's largest effective telescope for 45 years from its dedication in 1948 until 1993. It was finally surpassed in 1993 by the Keck 1 telescope in Hawaii. Now, we're beginning to move out of observations from here on the Earth, and now we're moving into the space age. Of course, in 1957, the first satellite was launched by Russia. That was the Sputnik satellite. Explorer 1, which is on your screen right now, was launched by the United States on January 31st, 1958, and was the nation's first successful satellite, marking its entry into the space race. Developed by the Army and the Jet Propulsion Laboratory to counter Soviet Sputniks, it discovered the Van Allen radiation belts using an onboard cosmic ray detector, and that 30-pound satellite stayed in orbit until 1970. I should point out that the Sputniks, they went up, and very quickly they came down, re-entering the Earth's atmosphere. But at least with our satellites, our early satellites, we didn't just send them up there to say, hey, we can send something into space and orbit the Earth. We sent something up into space to orbit the Earth to actually do something to, in this particular case, make observations, again, of the Van Allen belts that circle or encircle our planet. And then we moved on to putting people up in space, astronauts. The person you see on the right was Alan Shepard. Alan Shepard was the first American to go into space. It was a suborbital flight. It only lasted 15 minutes. He shot out of Cape Canaveral, went up about 100 miles, and then landed several hundred miles offshore in the Atlantic Ocean. The gentleman on the left is John Glenn. In February of 1962, it was John Glenn who became the first American to orbit the Earth 3 times in his space capsule, his Mercury space capsule. And once we proved to ourselves that we could put people in space, then we moved on to a bigger target, the moon. President John Kennedy was the one who set the stage and set the course for our program to land on the moon. To Congress in 1961, he said, now is the time to take longer strides. Time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth. And he said, I believe this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. Here he is now addressing Rice University on the nation's space effort. The speech was on September the 12th, 1962. The aim was to bolster public support for his proposal to land a man on the moon before the end of the decade of the 1960s and bring him safely back to the Earth. Whoops. Sorry about that. Hang on. Hang on. Sometimes you get technical difficulties.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
And many of you, I would hope, may remember that incredible Sunday night in late July of 1969 when down climbed a man, rung by rung, until, at long last, the footprint of a human being was set onto the dust of the surface of the moon. Man on the moon. And how many of you were among the hundreds of millions who on that night were glued to our television screens to watch two men cavorting on the surface of the satellite of Earth, the moon, and also planting the red, white, and blue, the American flag. Through ghostly images, those first televised images were of man walking on the surface of the moon.
The EDA is progressing beautifully. I believe they're setting up the flag now.
You know, they started up behind time on this.
I guess you're about the only person around that doesn't have TV coverage of the thing.
Yes, this is the flag, not the core sample.
That's all right, I don't mind a bit.
I constantly doesn't mind a bit not having television right now.
How is the quality of the TV? Oh, it's beautiful, Mike, really is.
There it is, a U.S. flag on the surface of the moon.
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the window. Beautiful, just beautiful.
That flag is on a frame. There is no wind to hold it out like that, of course. It's a 3x5 flag, and it's got a frame of its own to hold it out. Nothing more really is needed here, but it does seem that there ought to be some music.
Very good.
Hard to believe that 7 years later, 7 years to the day, July 20th, 1976. This was July 20th, 1969. July 20th, 1976, we did it again. We went to another planet. We landed a spacecraft, the Project Viking space probe, on the surface of Mars, unmanned, but it was the first safe landing on the surface of another planet. And again, it happened on the same anniversary, the 7th anniversary of our first flight to the moon in July of 1969. In July of 1976, here we are landing on Mars. And here you'll hear the actual report by an NBC reporter at the Jet Propulsion Laboratory when they received confirmation that we had actually landed on the surface of Mars.
There is a delay between the landing and confirmation because of the vast gulf of miles lying between Mars and Earth, and so it takes 19 minutes to find out whether or not indeed the lander is on the surface of the red planet. Those 19 minutes are just about set. There you can probably hear the cheers. Touchdown is confirmed. The Viking has landed on Mars.
And of course, after that amazing event, again, July 20th, 1976, after that amazing event, the first photographs which proved that no, there weren't Martians walking around on Mars. In fact, there you see the rusty red landscape of Mars, nothing but rocks. And we have launched and landed other space probes on Mars ever since, and we're still looking for signs that life may have existed in the past or may exist even now on the surface of the red planet. Still other objects that we have placed into orbit, for example, the Hubble Space Telescope, a large space-based observatory launched by NASA in 1990 that orbits the Earth, that provides exceptionally clear, high-resolution images and the data of the universe in ultraviolet, visible, and near-infrared light. It is a pioneering tool that has fundamentally changed astronomy by allowing scientists to study distant galaxies, star formations, and planets without the distortion of Earth's atmosphere. And here is the newest space telescope, the James Webb Space Telescope, the largest and most powerful infrared space observatory ever built, designed to look back 13.5 billion years to see the first galaxies born after the Big Bang. Launched on December 25th, Christmas, in the year 2021, it is a partnership between NASA and the European Space Agency and the Canadian Space Agency as well. Now here is a photograph that should not exist. It was taken not too long ago, April the 6th, 2026, by a camera mounted on one of the solar array rings of the Orion space probe. Not by a human being, not by human hand, not through a window, but by a camera pointed back at the spacecraft from the outside, from deep space, from 250,000 miles away from the Earth. Look what's in this single frame. On the left, Integrity, the Orion Integrity, the spacecraft carrying 4 humans, the first to travel this far out from the Earth since Apollo 13 in 1970. There is the famous worm logo of NASA that's right on the spacecraft itself. The NASA worm logo visible on the hull. Solar panels catching sunlight here. On the right, here is the moon, the far side of the moon, the hemisphere that never faces Earth, cratered, ancient, filling the frame with 4 billion years of impact history. And in the upper right-hand corner, barely visible, a tiny, bright crescent, Earth, home, 250,000 miles away and shrinking. 3 objects, 3 scales, a spacecraft, a world, a planet. This is not a composite. This is not a render. It's not CGI. It's just a single frame taken automatically during the 6 minutes before 4 human beings disappeared behind the moon, losing contact with the Earth for 40 minutes. Amazing. Sometimes the most profound photographs in history are often the ones that nobody had planned to take. Now, there are people out there who still believe that, why is it that we're doing this? Why is it that we are going out into space? Isn't there some way that we could use the money better than to go out and, let's say, go to the moon and collect a few rocks? I saw about a month ago, I don't know how many of you have Me TV on your cable system. Me TV, late on Sunday nights at 11 o'clock, reruns All in the Family. Remember that TV show, that comedy show from over a half a century ago? I can't believe I'm saying a half a century, but it indeed is the case. In 1971, there was an episode that they ran about a month ago where Archie Bunker, the main character in All in the Family, he was talking with his next-door neighbor, Mr. Jefferson. He was sitting down with him, and Mr. Jefferson noticed that there was an ashtray with the Apollo insignia on it in the Bunker home, and he said to Archie, "Don't you think we should be able to spend some money on poverty, be able to, create a few jobs? What's the use? What's the sense of having us have this program to go to space?" Well, I'll ask you this question. How many of you spent time just in the last few days in front of a computer, either a laptop computer or a desktop computer? How many of you used a phone, not just to call somebody, but to send a text, to take a picture, to check on some particular website or use an app? How many of you, with perhaps members of your family, recently sat in front of your big flat screen television to look at a program with your wife and with your children perhaps? Well, I have to tell you, all of these things that you enjoy today, all of these things, some of it you can't even live without your phone, all of this came out of the space age, was developed or beginning to develop in the late 50s and early 60s. I remember seeing at the New York World's Fair in 1964 an idea that we would have these things in the far distant future. And now we do have them. And again, these are things that all came about out of President Kennedy's decree to try to go to the moon. And along the way, we developed this technology and developed these wonderful and so many other different things as well. And by the way, Mr. Jefferson, if you're listening, I don't know if he is, he may even be dead by now after 50 plus years, but if he was here, I would tell him, create a few jobs. At the time when NASA was in full-scale moon mode in the late 60s and early 70s, NASA employed 400,000 people, the best and brightest in this country, to help us design these things, the technology, and to get us all the way up to the moon. Now, here's something interesting. How fast does light move? A beam of light goes 186,282 miles in a single second. In 1 minute, that beam of light has gone 11,176,920 miles. That's in just 1 minute. In 1 year, 5,878,487,000,000 miles. That number, nearly 6 trillion, if you will, that number is what astronomers refer to as one light year. So this is the 250th anniversary of this great country of ours. 250 years. So how far would that light beam go over a span of 250 years or 250 light years? It would go 1,460,962,200,000,000 miles. That's how far away 250 light years is. And you could do something as a stargazer that nobody else can do. You could look back in time, go outside the next clear night, look up and find the Big Dipper. You've, I'm sure, seen the Big Dipper. There's the bowl, there's the handle. Follow the arc of the handle of the bowl of the Big Dipper, the handle of the Big Dipper. Make an arc and make that arc to this star, Arcturus. Follow the arc to Arcturus. Now, Arcturus is a bright yellow-orange star, and it's only about 36 light years away. But if you were to continue that arc beyond Arcturus, you would come to this star here, not as bright, and also bluish in color, not orange like Arcturus. Follow the arc to Arcturus, and then you speed to Spica in the constellation of Virgo, the young lady. Here's another viewpoint of it here, where you can see how you can swing that arc through Arcturus and go to Spica. Spica is, as best as we can tell, 250 light years away. Now, it may be off by several light years either way, but as best as we can tell, this star is, in a rounded figure, a rounded number, 250 light years away. So when you look at that star tonight, if you get a chance to look at it in the real sky, swinging that arc from the Big Dipper's handle to Arcturus and then on to Spica, when you look at Spica, you are looking at light that traveled from that star on its way to Earth at the time of the signing of the Declaration of Independence. Isn't that amazing? You're looking back in time, you're looking at light that started toward us all those years ago when this country first found independence in 1776. So I would say that instead of calling that star Spica, as is the proper name for it, maybe this year, and for this year alone, we should refer to Spica as America's star. And that's the story. That's the story of how astronomy and space science developed over a span of, again, 250 years. Amazing. And I want to just end here with the following notations. 1, Benjamin Franklin had shocking ideas, didn't he? 2, John Hancock signed big time. 3, Alexander Hamilton never threw away his shot. 4, the founders inked history. 5, they framed freedom perfectly. 6, they were all rebels with a clause. 7, they had quill power. 8, they had bold declarations. 9, they were all star-spangled smart. And finally, number 10, and I guess this would finish this off, they made history wonderful. Thank you very, very much. I hope all of you enjoyed and found this very interesting talk. And if you have any questions or comments or anything you'd like to ask, I'm available right now for that. Just let me know.
Wonderful talk, Joe.
That was
classic,
fantastic,
Joe.
Joe.
Excellent.
Oh my God. I have a half a dozen questions, but I'll let people go first.
Let me go, because we're talking about satellites and all this stuff. I was kind of wondering how you feel about all the satellites that we're getting now, and how they interfere with astronomical observations.
What was the question again now?
How do you feel about all these satellites that we're getting now that are being put up there?
I feel very badly about it. You know, it's hard enough. It's been hard enough for us to, in our fight to get light pollution reduced so that we could be able to see the stars again in suburban locations and places that used to be able to have a nice dark sky and not have a dark sky anymore. But now, on top of all of that, we now have to be concerned about all of the light that, not all of the lights, all of the satellites, as you point out, that are being put into orbit that are causing on long-term exposures, long streaks on the photographic plates and photographic exposures. I saw a picture of the Milky Way by someone who took an exposure over a span of an hour, and it looked like there must have been hundreds of lines crisscrossing that view because of those satellites. I have nothing against putting satellites into orbit to help us with our, let's say, telephone services or to observe weather observations, weather satellites, but this has just gone too far. And sadly, the man who has all the money thinks that he could do anything and everything that he wants. And nobody out there has, in our government or any other government has apparently done anything to try to stop him from putting so many of these satellites up into orbit. It's a damn shame. Don't want to use any curse words or words that, but it is. It's terrible. There are far too many satellites up there now, and they have intentions of putting even more. And in fact, there's even one suggestion of putting a satellite up there that's going to act like a gigantic mirror and bounce sunlight off of that giant orbiting mirror so that it could provide light down on the surface of the earth, permanent daylight or twilight for cities that don't have light. It's crazy. But you know, that's, I guess, man can't help himself. Once he gets started on something, he has to keep on, you know, just trying to extend himself. And in this particular case, again, I think the number of satellites up there already is far, far too much.
Out of curiosity, Joe, on the satellite subject, since all these other satellites are covering everything, what are all the other ones for? I mean, what are they all for?
Well, the satellites are being put up 20 and 30 at a time by Elon Musk.
Yeah, but for what reason do you think?
To give you better phone coverage, people who live in places that don't have good phone service, for example.
Well, internet is the main thing. It's
these are the Starlink satellites.
Right.
Oh,
so
okay.
you get internet through an antenna.
Right. So now you can have internet all you want. You can go to the South Pole and have your internet service thanks to satellites that are put up into orbit. I can understand. The thing I don't understand is why do they need so many?
Well, they keep coming down too. By the way, because of friction.
Yeah, that's what I was curious about that. I wanted to ask Joe, Can we still go see the I always say this word wrong. Yerkes? Is that how you pronounce the Yerkes telescope? Yerkes?
The Yerkes telescope?
Yeah.
I believe it's still open to the public. I believe they do have. I guess if you were to go online and check for a schedule, that they would certainly have public viewing times for being able to see the actual telescope. It's still there, and I believe it's still in operation.
Okay. And talking about Sputnik, was it just the one Sputnik they put up?
No, they
Or
put up.
did they put up more than one?
Yeah, they put up several different Sputniks, but the thing is that they were nothing more than basketballs with antennae sticking out from it, and they made a beeping sound. There was really no science aside from being able to create the beeps and tell everybody, "Hey, listen to me. I'm up there and you're not." But our early satellites, were sent up with a purpose. As I said, Explorer 1, the first one, investigated the radiation belts of the Earth and were able to send back invaluable data about the Van Allen radiation belts. And they stayed in orbit. The Sputniks usually came down after only a few months.
Right.
But Explorer 1, the first satellite that the U.S. put up, didn't come down until like 11 years later.
I remember going to the World's Fair because I'm your age, Joe, and we it was the first time they had these uh, Flintstone looking rock plate um, structures that you could go into. And I remember my brothers and I going into one of them, and you could call. We called our father, and the four of us were there, and we were talking to him without the phone. It was like it was the first kind of like, oh look, we're talking to Daddy, and he could hear us perfectly, but we didn't have any phones or anything. It was kind of like amazing, and it was the first time I saw a microwave oven. And my mother, we all made microwave hot dogs in one of them. And the other thing, I'll date myself. What is your name, young lady? Yeah, what is your name?
Heather.
Hi, Heather, because I called you
Hi.
Source before. I didn't notice the library. Heather, I'll date myself. The first astronomy book my mother ever bought me, George, Andromeda, is still a nebula.
Yes,
They hadn't updated the book yet.
many of the early 20th century astronomy books still refer to it as the Andromeda Nebula. And now, of course, we know it's a galaxy. And I know that it's amazing to think that the object that we're looking at, the Andromeda Galaxy, is actually 2.5 times bigger than our own galaxy. It is a galaxy that contains about 1 trillion stars, and yet it looks so dim and so tired looking. But you have to understand that light has been traveling towards you for 2.5 million years.
I've read, Joe, that actually they're reconsidering the size of the Milky Way. It's a little bigger, so it may not be 2.5, maybe 2.25.
Well, right now the references are saying 100 to 400 billion stars. So
Wow.
even at the top end of that 400 billion, that's still 2.5 times less
Oh,
than
you're
the
talking
1
about
trillion
number of stars, not the actual
Size.
size. Yes.
And I had one more question, then I'll let everybody else go. Joe, any idea what telescopes, if any, maybe he didn't, Einstein was using at any time? Was he actually, did he have, I guess his brain probably didn't need him to be looking through any telescopes. I was just curious.
I'm sure he looked through a number of different telescopes in his lifetime,
Yeah, but it wasn't
but
necessary
but he
for
was
him.
but he was a desk man to the end.
Yeah.
He was
Okay.
probably, there are people who, there were a British astronomer, Alcock, discovered like 13 nova and like 20 comets or whatever, and he had actually memorized the whole star fields. He didn't need an atlas. He memorized the positions of literally tens of thousands or hundreds of thousands of stars, and out of that he was able to pick out a new star or a faint
Oh my
comet.
gosh.
Now he was very much into that, but I'm sure he wasn't into doing the calculations. Einstein, on the other hand, I'm sure he was more happy sitting behind his desk and doing his calculations, and every once in a while he would look through a telescope. But
Right.
that was his gig.
That was his gig. Cool. This is great. Heather, I'm going to tell Joe that he needs to come and do this for either the Westchester amateur astronomers or the New York amateur astronomers. This is a great, great talk, Joe.
Yeah, he's wonderful.
Thank
We've
you.
had Joe here a few times, and he always does a fantastic job. Thank you so much.
Well, thank you. I don't want to cut this off, but now in about 15 minutes, I have to appear on a podcast called the Joe and Joe Weather Show. And I do it with a friend of mine, Joe Chiappi. He and I are retired on-camera TV meteorologists. And when the TV station said, "You're too old and we don't need you guys anymore," we decided we'd go on YouTube and we'd do our own show each night at 7:35. And so that's where we are, where I'll be in about 15 minutes. So I got to get ready.
Okay, great. maybe George and I will catch you over there.
And thank you, everybody, for joining us today.
Thanks,
And Joe,
Heather.
All right, thank you for organizing.
Thank
Joe.
you. Hope to be back.
Have a good night.
Bye-bye.
Clear skies, as they say.